This video walks us through the procedure to generate an ROC curve in order to visualize model performance. Here, I've created a table in a spreadsheet tool for the sake of the clarity of my writing, but I could use these exact same steps with a piece of paper. This is because I'm not using any computational or math features of this spreadsheet besides division, which you can replicate with a simple calculator. You'll notice that in these tables, typically the actual features for the data are omitted. We don't care about those. We're only interested in the model's prediction score and also the true class column, which reflects the true label of the data. I've also written down the procedure to plot the ROC curve one more time. It's over here, just so it's in front of us. In a moment, we will introduce a decision criterion threshold, T, and accept any prediction of class P for any model score above threshold T. We are going to compute the true positive rate and false positive rate for every value of our threshold T as it is varied from 0 to infinity. Recall that the true positive rate can be computed as the number of positive cases that are correctly classified over the total number of positive cases, and the false positive rate can be computed as the number of negative cases incorrectly classified over the total number of negative cases. In this example, counting the number of negative cases gives us a count of 10. 5, 6, 7, 8, 9, 10. Similarly, counting the number of positive cases also yields a count of 10. 10 is a nice convenient number to divide by to get the true positive rate and true negative rate. Over here on the right, I have a table showing the current value of T and the corresponding true positive rate and false positive rate. This is what we will plot in the end. We need to begin with our predictions sorted in order of descending prediction score, and I start my threshold T at 0. To help with counting, I've created two new columns to count true positives and false positives. I'm going to start at the bottom here at data sample number 20 and move upwards. However, you could equally well go the other way from top to bottom as long as the data is sorted in order of prediction score. That's the important part. Recall that our criterion accepts any prediction above the threshold T, so that means for a threshold of 0, we will accept all of these predictions as predicting class P. So for this first one, instance 20, our model predicts class P. Here, it indicates that the true class is N, so we mark this as a false positive. On the next one, sample 19, the true class is P, and our model will predict P, so this is counted as a true positive. For data sample 18, the true class is N. However, our model predicts P, so this is a count for false positive. At instance 17, or data point 17, the model predicts P, and our true class is also P. So in this case, we count it towards our true positive count. At this point, you might want to pause the video and fill in the rest of the table yourself to see if you follow the same reasoning. Okay? So 3, 2, 1. Are you back? Data point 16 In this case, the model predicts P, and the true case is N, so this is counted as a false positive. The same thing happens with case 15 and 14. Data sample 13, the true case is class P, so this is counted as a true positive. Instance 12, the true class is N, so this is counted as a false positive. Instance 11 indicates a true class of P. Our model predicts P, so this is a true positive. Instance 10 has a true class of N, so the prediction of P is counted as a false positive. Instance 9 has a true class of P, so the prediction of P is true. Instances 8 and 7 are both class N, so they're both counted as false positives. Instances 6, 5, and 4 are all P, which will match our model's prediction of P. These are all true positives. Instance 3 indicates the true class is N, however our model will predict P, so this is a false positive. Instances 1 and 2 are both class P, so the predicted class of P will be correct and true positive. So all this work was in order to compute one point in ROC space. For a threshold t of 0, we counted 10 true positives and 10 false positives. Since we have 10 positive cases, this gives us a true positive rate of 10 divided by 10, or 1. Similarly, since we have 10 negative cases and the false positive rate is 10, we again divide 10 by 10, giving us 1. Don't worry, computing the other points is going to be a lot less work. Next, we increase the threshold to the next value observed in the table. Here, that's 0.1. Now, we repeat the same procedure to count the true positives and false positives for this new threshold. Fortunately, as we'll see, increasing this threshold each time only changes a few counts in the table. Behold, with a threshold of 0.1, we say that only cases that have a prediction score greater than 0.1 will be considered to be predicting class P. This means that starting with sample 20, we now see that our criterion does not accept this as a prediction of class P. Therefore, it is not a false positive anymore. However, we see that data sample 19 will be predicting the same way using this new threshold. So will 18, 17, and all the rest of the instances. So by changing this threshold, we are only changing one prediction each time. If there's multiple predictions with the same score, not shown here, this could potentially change the count by more than one every time the threshold is increased. Now, with this new true positive count and false positive count, we can compute the true positive rate and false positive rate for this threshold. The true positive count is still 10, however, now the false positives have been reduced to 9. This gives us a false positive rate of 9/10 or 0.9. Next, we again increase the threshold, this time to 0.3, and we recount. What changes this time is the predicted class for data sample 19. This goes from P to N, which reduces the true positive count. There are no other changes, so the false positive count remains the same. Computing our TPR and FPR for a threshold of 0.3, we get 0.9 spreadsheet. And 0.9 respectively. Next, we increase the threshold to 0.33. This means that sample number 18 is no longer counted as a false positive. This reduces the false positive rate by 1, making it 8 over 10, or 0.8. This also doesn't change the true positive rate, so we record that in our table. Next, we increase the threshold to 0.34. This means that the prediction for sample 17 changes and is no longer counted as a true positive. Now, the true positive rate becomes 0.8 as well. This was for threshold 0.34. We again increase the threshold now to 0.35, and we see that sample 16 no longer counts towards the false positive rate, making it 0.7. I suggest pausing the video now and compute the rest of the table by increasing the threshold until it is infinity, or at least higher than the highest prediction score. This will usually never be higher than 1. It's 0.9 in this case. When we come back, I'll do the last 5 with you, and then we'll plot the result. Alright, we're back and down to the last 5 data points. Check your answer with the table to the right. When you're ready to move on, let's do the last 5 points together. Ready? When we raise the threshold to 0.55, the true positive count is reduced by 1 because this point is no longer being classified as being class P, which was correct. Now the TPR becomes 0.3 because there's only 3 true positives left divided by the total count of 10, yielding 0.3. This does not change the false positive rate. Then, when we increase the prediction threshold to 0.6, we see again that the number of true positives is going to be reduced by 1, giving us a count of 2 and a true positive rate of 0.2. When we raise the threshold to 0.7, there will be no more false positives, making the false positive rate 0 for the rest of the table. In this case, the true positive rate is unchanged. Finally, as we raise the threshold to 0.8, 0.9, and beyond, we see that the remaining true positive count goes down by 1 each time to 0.1, and finally 0. This completes the table. Once we're past 0.9, we can continue to increase the threshold to 1.0 and then further on to infinity without further changing the table. We are now ready to plot. In this last step, I'm showing what this ROC plot would look like when plotted. Obviously, on the exam, I will ask you to sketch it as best you can on paper. Notice that we do not plot the threshold anyplace. It is only used in the generation of the true positive rate and false positive rate, which are plotted against each other, with the false positive rate on the horizontal axis and the true positive rate on the vertical axis. Normally you would draw a line connecting these points.